All right, let's jump right in and tackle a concept in probability that trips up a ton of people. The difference between something being mutually exclusive and something being independent. They sound kind of similar, but as we're about to see, they're worlds apart.
So let's start with the question that's at the heart of all the confusion. I mean, think about it. If two things can't possibly happen at the same time, doesn't that kind of make them unrelated? Your gut instinct probably says, yeah, that makes sense. But here's the crazy part. In the world of probability, that gut feeling is, well, it's dead wrong. Let's break down why.
Okay, so to really get to the bottom of this, we need to be super clear about our definitions. First things first, let's talk about what it actually means for two events to be mutually exclusive.
It's really exactly what it sounds like. If you have two events, we'll call them A and B, and they're mutually exclusive, it just means there is no way they can both happen at the same time. It's one or the other, but never both. If one of them occurs, the other one is automatically kicked out of the picture. And, the real world is just full of these examples. When you're driving and you get to an intersection, you can turn left or you can turn right. You literally cannot do both simultaneously. Or think about a coin toss. It's either heads or it's tails. You can't get both. One outcome completely excludes the other. It's that simple.
Okay, check this out. This is a perfect probability example. Imagine you roll a standard six-sided die. Let's say event A is rolling an even number, a 2, 4, or 6, and event B is rolling a 3. Can those two things happen on the very same roll? No way. It's just not possible. They are 100% mutually exclusive.
And mathematically, this is as clear-cut as it gets. The test is super simple. You just look at the probability of A and B happening together. That little symbol in the middle just means and, or the intersection. If that probability is 0, and I mean exactly 0, then boom, they are mutually exclusive. Okay, got mutual exclusivity, good. Now let's switch gears and talk about our second big idea, independent events. And this is where that gut feeling we talked about really starts to get us into trouble. Because independence is all about a totally different concept, influence. So for two events to be independent, it means the outcome of one has absolutely no effect, no influence, no impact whatsoever on the probability of the other one. If I tell you what happened with event A, it gives you zero new information about the chances of event B happening. They're in their own separate worlds.
The classic example that everybody uses is tossing a coin and rolling a die, right? The coin landing on heads doesn't magically change the odds of the die landing on a 4. It's still 1 in 6. The two processes just don't talk to each other at all.
And this right here, this is the most important distinction. Remember how mutually exclusive events could not happen together? Well, independent events often can. You can absolutely flip a coin and get heads and roll a die and get a 6 at the same time. The key idea for independence isn't about coexisting, it's about influence. Does one mess with the odds of the other? For independent events, the answer is always a big nope. And of course, this leads us to the math test for independence. If two events are truly independent, then the probability of them both happening is just the probability of the first one happening multiplied by the probability of the second one. Simple as that. Okay, so now we have our two big ideas on the table. Mutual exclusivity, that's the can't happen together rule, and independence, that's the no influence rule. So let's finally bring them together and solve that puzzle we started with. This is the big one. This is the whole shebang. Can an event be separate in the sense that they can't happen together and also separate in the sense that they don't influence each other? It's a real head-scratcher. Let's use the math we just learned to figure it out.
Okay, stick with me here. Let's just walk through the logic. First, let's just pretend for a second that two events can be both. All right, if they're mutually exclusive, we know their joint probability, the chance of them both happening, has to be 0. Got it. But second, if they're also independent, then their joint probability has to be PA times PB. So if both of those things are true at the same time, then it has to be true that PA times PB equals 0. Now think about that. How do you multiply two numbers together and get 0? At least one of them has to be 0. This means either the probability of A is 0 or the probability of B is 0. So unless one of your events is something that's literally impossible to begin with, it just can't be done. It's a logical impossibility.
And that leads us to the big, surprising reveal, the answer to our puzzle.
Being mutually exclusive isn't some special kind of independence. It is the absolute opposite. It's a form of perfect, incredibly strong dependence. And if you really think about it, this makes total sense. Let's go back to our die roll example. The event of rolling a 3 and the event of rolling an even number. If I tell you, hey, I just rolled a 3, what do you now know about the chances that I rolled an even number? You know the probability just dropped to 0. It's impossible. So me telling you the outcome of the first event gave you perfect information about the second one. That is not no influence. That is the most influence you could possibly have.
All right, let's wrap this up and talk about why this isn't just some abstract math puzzle. This is a seriously important critical thinking tool.
This table just lays it all out so clearly. Let's just run through it. For mutually exclusive events, the core idea is they can't happen together. The math test is that their joint probability is 0. And the final verdict? They are strongly dependent. Now, for independent events, the core idea is no influence. The math test is you multiply their probabilities. And the verdict? Well, they're independent. Seeing it laid out like this just makes that contrast undeniable.
And why should you care? Because mixing these two up leads to really bad calculations and terrible decisions. It doesn't matter if you're an engineer calculating the risk of 2 different systems failing, or a scientist trying to figure out if your experiment's results mean anything. Getting this right is absolutely crucial.
And that really just leaves us with a bigger question to chew on, doesn't it? We've seen how in the world of math, 2 things being separate definitely doesn't mean they're unrelated. So where else does that pop up? In our jobs, in our relationships? What things do we treat as being totally disconnected when actually they have this hidden, powerful influence on each other? It's a great thought to take away from all this.